He is telling today it will. You can leave. No issue. You can leave. I will be there today. No issue.
So good afternoon, everyone. Thank you for joining and greetings from GIZ India. My name is Sushovan. I'm a technical expert at GIZ India working on electric mobility front. Till people keep on joining, we will at least start with the intro, with a small overview of the entire workshop that we are about to undertake in this session. Firstly, thank you again for joining today's workshop. We are delighted to announce the e-launch of two of our reports that have been developed under the Nationally Determined Contributions Transport Initiative for Asia, that is NDCTR's India component. This workshop is also part of our flagship event, that is Transport and Climate Change Week, that is currently being undertaken in Germany. Today's event will specially be divided into two sections. The first section would be one where we would be launching our report on battery ecosystem, a global overview, gap analysis in the Indian context, and way forward for ecosystem development. This report has been developed with Deloitte India. In the second section, we would be launching our report on international review on recycling ecosystem for EV batteries. This report has been developed in collaboration with IIT Bombay and Agora Verkehrswende. So without further ado, I would like to start the workshop. But before we start, there are few housekeeping rules that we would want to follow for the efficient flow of this workshop. And first is, I would like to request all the participants, especially who are not the speakers, to kindly keep your mic and video turned off for the entire duration of the workshop. Also, for the entire workshop is being recorded. So in case anyone would not like to be a part of the recorded sessions, I would kindly ask you to consider opting out of this workshop. So with the housekeeping rules set, let's start with our first session. So for the first session is on, as I said, is on battery ecosystem, which is a global overview, gap analysis in the Indian context, and way forward for ecosystem development. So I would like to invite Dr. Winfried Damm, head of the Indo-German Energy Program of GIZ India, to provide his key opening remarks and welcome address.
Thank you very much. Sorry that I'm not displayed because I'm traveling right now with the Honorable Minister from MNIE out in Germany. I'm really delighted to have you all here on board. And it's so important to have this topic pushed forward. While traveling in Germany, we see the importance of the transformation in the transport sector of becoming non-fossil. And the minister is really appreciating to show the infrastructure coming up and the fast development in the specific area. Because transport obviously is only one sector. We need to have this coming to non-zero carbon in all sectors. And transport is right now the leading sector. And we appreciate that electricity will be the key thing for the main areas of transport. But of course, we are investigating and exploring how hydrogen might come up as well. But this is a different topic for the heavy vehicles and vessels and aviation. And now I wish the conference all the best and looking forward to the details, because learning in India that importing of batteries is probably not the very best way for the long term. But for initializing it, it's very helpful for India because they import raw materials and the batteries can be used for a very long time. So we are discussing right now warranties by OEMs of 8 years or even 10 years, cycling times of 5,000 plus, and 100,000 kilometers or 150,000 kilometers or similar distances. After that, those batteries are not useless. They still have a very significant opportunity to be used in other applications, second lifetime. But even afterwards, when the battery is not having a significant capacity left, there might be a chance to utilize the chemistry of those batteries. And then we are into the topic of next use of those battery chemicals altogether. We need to start the discussion in India to do this. And therefore, I'm so grateful that we have today the opportunity to do so. Thanks again for joining, and I wish all the best. And sorry for this mobile application here being in use. Thank you.
Thank you, Dr. Damm. Thank you for the thoughtful words and the warm welcome. Next, I would like to invite our special guest, Mr. Sudhendhu Sinha, who is an advisor in infrastructure connectivity and electric mobility vertical of NITI Aayog under Government of India, for his special address and for launching the report. Welcome, sir.
Thank you, Sushovan, Dr. Dan, all the representatives of GIZ, Deloitte, Agora, and the entire team that has worked together to pull off this particular report. Let me congratulate you, and I'm sure that the substance, the content, the impact that this report will have, that is going to be absolutely phenomenal. So as far as India is concerned, if I might say that we are very, very aspirational with respect to the battery, especially the advanced chemistry cell manufacturing in India. So since last 9th June of the year last 2021, the advanced chemistry cell program of some close to $3 billion was rolled out, and the idea was that absolutely a quality product with a lot of emphasis on make, with a sight in view of developing India as a manufacturing hub, and finally to support electric mobility in a big way, as well as the storage of renewables in a big way. This particular program was rolled out. Now, on October 22nd, that was in a time span of 4.5 months, we initiated the RFP. The RFP was floated. The last date was January 14th of this year. And finally, on March 28th, we issued the letter of award. So in a way, almost in a time span of close to 9.5 months, the entire process was wrapped up. Now we have identified that who are the manufacturing people, the industry players who are going to set up these advanced chemistry cell manufacturing units in India and will be supported by Government of India initial incentives. This will be to the tune of 50 gigawatt. To that, there are others also who will be participating, who will be in this battery manufacturing ecosystem. You know, when we had started, there was a lot of diffidence because we were thinking that we might not get players who will be ready to agree for and invest for and plan for supporting even 15 to 20 gigawatt. But it received an overwhelming support. And when the bids were opened, we found that there were takers for 130 gigawatt hour. So that is the kind of response that we received from industry, both domestic as well as global with respect to our manufacturing of advanced chemistry cell program. That is the reason why this battery ecosystem becomes absolutely significant. And that is why probably the report, and I was going through different program that you have, module that you have created out of it. That is really wonderful. It will bring a lot of global learning to us. It will give lot of new perspectives which otherwise we might have missed also. And definitely it will help us. This particular report is going to help us in taking our own advanced chemistry cell manufacturing program forward, recalibrating it, revising it if need be. So that is the intended impact of this particular report that we are planning to launch today. And again, a lot of congratulations to all the partners, all those who have been directly involved, and of course providing support in kind of scripting, planning, the content of this particular report, and I'm sure that is going to be very, very impactful. And let me tell you that among so many production-linked incentive schemes that Government of India has launched, almost 14 of them with a huge investment involved in the country, and a lot of implications, financial implications for the government exchequer. Probably two of them are most aspirational, most sunrise sector. One is definitely the solar panels, and second is this advanced chemistry cell. That is the reason why we all were after it. We will just completely immersed into it so that we are able to take this thing forward. And of course, initially we had a lot of roadblocks, lot of confusion in between, but finally it has seen the light of the day. Now the players who have been so decided, they are already getting into the final manufacturing, setting up the manufacturing units. We have given them 2 years time to set up their manufacturing units, and of course after the program, actual production as well as the incentive, that linkage will start for a period of 5 years. There is a lot of emphasis on localization. On the first year itself, they have to come out with some 25% of localization. Similarly, on the last year, they must have within 5 years, 3 years, they must have 60% of localization. That is the kind of idea. And of course, the quality parameters that we have decided, they are the best in the global class, so that these manufacturing, these Make in India advanced chemistry cell, they become really a kind of something that can see a global market outside, and that can have all the acceptability, all the quality parameters, all the desired standards and specifications into them, so that they have got universal acceptance. So, and then again, congratulations to the entire team for this particular report. And I'm sure at least for one, I'm going to read through this report, and my team would be reading this report, so that we get the maximum benefit out of it. So thank you. Thanks a lot. So Shoban, should I go in for the lunch?
Yes, sir. Please go in for the lunch.
Okay. Great.
Thank you, sir. Thank you so much for the kind words, and thank you for motivating the industry as well by giving a glimpse of what the future might see and what the industry might see going forward. Thank you so much for being a part of the workshop, sir. Thank you.
Thank you, Sushovan. Thanks a lot. And I'm sure this will set up the supply chain in India for the entire thing. Thank you.
Thank you so much, sir. So now we would like to move ahead with delegating the findings from our report. For this, I would like to invite Mr. Anish Mandal, who is a partner at Deloitte India LLP, to take the discussions forward on the objectives of the study and its coverage. Anish, to you.
Thank you, Sushovan. Thank you, Dr. Damm. Thank you, Mr. Sinha, for the encouraging words and as well as re-emphasizing the importance of battery storage as a device and as well as its multiple use across the industry. So with that context, I'll just quickly present what the key findings of the report are. This is a study about a global overview gap analysis in the Indian context and the way forward for ecosystem development. As rightly pointed out, there will be a huge demand both from the traction or both from the EV segment as well as the stationary segment, and therefore what needs to be done in across the ecosystem is very important. And therefore this study came out or is apt as sponsored by GIZ, was felt that this is an appropriate study, which will be the key findings of it, the learnings of it will be used by several of the stakeholders. So with that, we'll be covering the background, hence what's the current context is and as well as the future context is that would define the role of battery storage. The brief description of what we have done, the approach we have followed in that assignment, and the key study findings, which you will see that we have covered the entire value chain across the segment, like the key, the EV battery technologies, what are the different technologies and as well as the research findings are, the battery standards that should be the way forward, the gap analysis of that, the policy and regulatory landscape, whether there are any gaps or whether there are any enablers which are required, the battery manufacturing, what are the kind of enablers we are looking in that segment as well, and then a detailed feasibility and analysis across the I would say the more important on the downstream, which is the swapping, recycling, and reuse. So swapping, of course, NITI Aayog has come out with a policy which gives a directional overview of how battery swapping should be followed in India. So we have done a detailed feasibility analysis about that on the commercial side as well. We'll have the key findings in the recycling and the financial analysis from there as well, and then the reuse segment of that. So that's the broad coverage from the perspective of the report. Now we go to the moving on, Chandan. Go to the background. Right. So this is not new to everyone. So just re-emphasizing the fact that, of course, we are all kind of committed towards the energy transition and as well as the emissions reduction. So 19 of the top 20 warmest years happened in 21st century. We are seeing numerous changes in the climate because of emissions, because of climate change. So therefore, it's high time that, of course, we are all committed as a part of global economy, as part of all the countries and as well as citizens, that we are committed to this climate change. Now, India's is also, of course, raised up to the fact since 2015 itself, Honorable Prime Minister Modi was the first one to unveil the vision for India in achieving 175 gigawatt of renewables by 2020. That's the undoubtedly the kind of the biggest or the largest, I would say, renewables addition ambition what we had, and now it's the target is revised to almost like 500 gigawatt of renewable electricity in India, and as well as a very steep target for EVs as well. So therefore, India's Panchamitra to counter the global warming and climate change, which are recently kind of committed as part of the Glasgow summit. The first one is reaching non-fossil energy capacity of 500 gigawatt by 2030. The second would be meeting 50% of energy requirement in energy terms by renewable energy by 2030. The third is, of course, reducing the projected carbon emissions by 1 billion tons by 2030. Fourth is reducing economy's carbon intensity by less than 45% by 2030 and achieving net zero by 2070. Now moving on. So if you take on the fact that transport sector itself, close to something around 13 to 15% of the emissions is results from the transport sector itself, and therefore achieve your, I would say, adopting electric vehicles is seen as one of the, of course, a transitionary evolution towards moving towards the decarbonization pathway in the transport segment. And also renewable energy. So if you move towards EV, there is a demand which is created towards electricity, and then electricity make it kind of green. So therefore, renewable electricity is again required for that, as well as the entire greening of the electricity supply. So renewable electricity is also kind of the preferred way forward, as we have seen in all the government's policy. Now, if you see both the demand drivers, the electricity mobility, and as well as the stationary storage demand. So these are the demand drivers for battery storage. And now, just to give you a fact that by 2070, if you are aiming to kind of do a net zero transition, so by 2050, somewhere around 450 gigawatt of battery storage is required just from the stationary itself. Having said that, then there is a much more bigger segment, which is probably 3 times the segment we're talking about in gigawatt hour times. Gigawatt hour segment. So that's the important battery. Talking about technology, what are the different standards which create the reliability and the health conditions of the battery. That becomes important. And once you have the batteries in the ecosystem, then how do you recycle it? How do you reuse it? How do you kind of control the entire value chain, monitor the entire value chain? That also becomes an important aspect. So with that, moving on. Sorry, can you move on? Right. So with that, the study aims to provide a global overview and perform gap analysis in the Indian context. Of course, we have looked at globally in all these across the areas. As I said, technology, it's always been evolving. And therefore, what are the different technologies that's going to be different standards which have already been placed globally, and what should be adopted in Indian context. So all that becomes a part of this study. So to provide a global overview of it and then assess the gaps and then accordingly do a way forward for the battery ecosystem. That's what we have done. Therefore, this study is uniquely kind of positioned for all the stakeholders to kind of adopt the key findings and accordingly take positions in the market, accordingly take initiatives, and for the policymakers also create those enablers which will enable the energy transition for India. Moving on. Right. So we have adopted a 3-pillar approach. The first one, of course, we did an extensive study on the domestic market review, and it's not a desktop studies. We have reached out to most of all the industry players, all the stakeholders, did primary service, did primary interviews, assess what's going on, what are the different challenges. So we have captured all that. The second would be the international market review. So we have consulted our international experts. We have extensively worked in our international markets. So we have captured those learnings as well. And third pillar, of course, as I said, so all this couldn't have been possible without the stakeholder consultation and your support. So we have consulted across the industry groups. It's not only the battery manufacturers, but also the recyclers, also the policy and regulatory bodies, as well as the entire ecosystem to capture all the insights what we have and present to you today. Moving on. Right. Now I'll invite my colleague Chandan Dikshit to go through the key study findings. Thank you.
Thank you, Anish. And good evening to everyone. The first section we will cover on our findings on the battery technology. Adarsh, if you can move on. So what we are finding is, and we are well aware of this fact, that at present the battery industry is dominated by lead acid as well as nickel-based chemistries. However, what we also know, and this is well known to everyone, that lithium-ion has been the preferred choice. It has already started making inroads in the overall battery chemistry, with LFP and NMC being the most preferred chemistries globally as well as in the country. Not only that, the lithium-ion technology itself at the cusp of evaluation, with other chemistries making inroads with continuous R&D. We will be seeing the likes of LTO, NCO, NCA, LMO, etc. also making inroads into the battery chemistries. Having said that, since lithium-ion, as we are well aware, it's it's prone to supply chain risks, and it depends on rare earth minerals. So there are other chemistries which are slowly or steadily will be forming some part to the extent that it will be replacing as a substitute for lithium ion, which is sodium ion, which we think, and based on our interactions, based on the R&D efforts happening, it could be a possible chemistry which would try to replace some part of the market. Primarily because it depends, it is not prone to supply chain risks, and it depends on abundance of minerals, and it also gives the energy density somewhere comparable to lithium ion chemistries. We have also seen other chemistries which are presently under R&D of the likes of metal air batteries, solid state batteries, high energy NMC batteries which have less cobalt content and high nickel contents. So all of these technologies are evolving, and we see that these technologies will slowly and steadily make inroads in the technology chemistry. But lithium ion will definitely be the technology of choice when it comes to the Indian market, at least for the next 5 to 10 years. Moving ahead, Adarsh. Within lithium ion, as I said, it's on a cusp of evolution. So the evolution can happen in two directions, as you can see in this illustration. One is a high energy route. In this route, what the R&D and manufacturers have been doing is improving the anode and the cathode, in the sense that the anode, the graphite anode, is slowly and steadily will be replaced by silicon-based anodes, which offer almost 8 to 10 times of energy density. In addition to that, nickel component in NMC batteries will be also slowly and steadily increasing. And nickel by its nature gives a high energy density to the overall NMC batteries. So the high energy route is one. And the second is the cost effectiveness route, wherein the efforts are also to bring down the cobalt content, because cobalt by itself is a rare earth material and it's prone to supply chain risk, and hence it adds most of the cost component. So making the batteries cobalt free and adding manganese to them will also help in improving energy densities, though not very appreciably as the high energy route, but definitely it is going to be a cost effective solution. And hence these are the two ways or the two paths which OEMs have been taking or will be taking in the future to improve the lithium ion chemistries. Yeah, and moving to the next slide. Yeah, so that's on the technology based findings on the implications which we have highlighted. Now, as we are all aware that evolution of chemistries depends on customer confidence and investor confidence. And that also relates to the fact that there has to be a suitable ecosystem or presence of adequate testing capabilities which can demonstrate the safety aspects, the performance aspects of these chemistries. And with the recent increase in safety concerns, as we are well aware in the industry, it becomes important to ensure that the extent of cohesiveness in all the safety standards or the performance standards, or whether they are apt, whether they cover entire cycle of tests, or whether something can be improved to ensure more and more chemistries can be subsumed under this, and more performance evaluations and safety evaluations can be done. So with that intention, we reviewed all the Indian standards, as well as we also did a comparison of international standards, specifically IEC, ISO, Senelec, GB, and the underwriter laboratory standards. We have reviewed the standards across all the 4 broad technologies: lead acid, lithium ion, and nickel based chemistries. And we've also reviewed the entire gamut of the spectrum of standards, ranging from safety standards, performance standards, recycling related standards, abuse testing standards, and all. Moving on. So what comes out is, if we compare Indian standards, if we evaluate Indian standards, we understand that it's fairly represented with all the chemistries. The lead acid, the lithium ion, nickel metal hydride, and nickel cadmium are fairly covered in the Indian standards. The one key, there are a couple of things which stand out. One is that on the recycling aspect, since we are well aware that when the country is targeting to have a lot of EV penetration in the country, there will be a substantial amount of batteries which are going to reach the end of life after, say, 5 to 10 years. And the second fact is that since we will be depending more and more on electric vehicles, and we should also be not prone to import dependency, as was highlighted earlier. So it becomes important to ensure that we have a robust recycling ecosystem, which again points to the fact that we should have guidelines for recycling. And that is one thing which needs to be taken into consideration and adopted. And there are several standards internationally which cover is recycling standards to a very detailed extent. That thing can be considered to be adopted, or maybe Indian standards could be drafted for recycling. But when we look at the performance standards and safety standards, it is fairly and very cohesively covered in the Indian standards. However, when we deep dive into the performance standards and safety standards, what we observe is, what we find out is there could be some areas where improvements can happen or some additional testing can be done to ensure that the batteries are robust and are also subjected to extreme abuse tolerance at the time of testing itself, so that they can withstand the real-time operating conditions. And this inference has been done when we have also looked at the international standards, what are the various tests they have been prescribing, and whether the same can be somehow considered in the Indian context. So with that intention, we have find out some key areas where the Indian standards could be improved. Adarsh, if you can proceed. Yeah, so as the first recommendation or the finding to say, which I already highlighted, India needs to develop its own standards or maybe adopts battery recycling standards, which are well covered for all chemistries internationally. If you see lead acid, lithium ion, nickel metal hydride, and nickel cadmium, you can see there are a lot of standards specified by IC, SAE, as well as ISO for recycling of those chemistries. That assumes significance. As I said, we need to have a circular economy to ensure that we are not dependent on imports for manufacturing, as well as we can use the metals and minerals from the end of life batteries and feed them into the overall manufacturing value chain. For lead acid and nickel based chemistries, when we compare Indian standards and international standards, what we observe is international standards have a testing requirement where they measure the rated capacity at multiple charge discharge rates, whereas Indian standards have 2 or 3 charge discharge rates only where the rated capacity is measured. Now, this assumes significance because a battery or a traction battery is subjected to multiple abuses in the real-time operating conditions when it's actually applied in the electric vehicle. So the capacities, the performance has to be measured at multiple charge discharge rates. So it could be as low as 1C or it could be as high as 10C. So that is one thing which can be considered in the Indian context, which is already there in a lot of the Indian international standards. For lithium-ion batteries, which are, as we all know, is the technology of choice for e-mobility segment, the Indian standards lack certain mechanical tests such as the drop test, penetration test, and the saltwater immersion tests, which are very robustly captured in IEC standards. Those tests needs to be seen how best it can be adopted, because those represents the mechanical abuse of batteries in real-time operating conditions, and suitably it can be considered for adoption in the Indian conditions as well. Moving on. Yes, again, for lithium ion, there are certain aspects which are very detailed covered in IC and SAE standards. To some extent, it is there in the Indian standards as well. But there are some of the additional tests, such as a thermal shock test, in which a battery is subjected to either a very high temperature or a very low temperature at an extended period of time to understand how it is reacting. Thermal cycling test, in which the battery is placed in a chamber and continuously oscillated in different operating conditions. It is cycled between a high temperature and a low temperature to understand how it is behaving. There are other tests like dewing test, measuring of the emissions from the battery to understand how much is the emissions content from it. Then other tests like the salt spray and the flammability test, which are there in UL standards, and UL is a robust safety related standard, as well as in SAE standards. This can also be suitably considered in the Indian context. Then the QCT standards include requirement for components such as the swapping battery enclosure. So it mentions how mechanically the swapping batteries should be connected and how the safety should be done for swapping batteries. Now, this assumes significance because we are not only looking at a EV charging infrastructure perspective, but we are also looking at promoting battery swapping business in the country. And in addition to that, specifically for hybrid electric vehicles, there is a standard of IEC which mentions how the cranking power should be given for batteries, how the battery should be given cranking power to start the engine. Those are also required because at multiple operating temperatures, at a very high temperature and a low temperature, the battery should be robust enough to support the operation of HEVs. And these are some of the recommendations which we feel can be adopted in the Indian context and which is suitably covered in a lot of international standards. Moving on. Right, the next segment is on the policy and regulatory landscape, and we have highlighted here what are the key findings for adoption in the Indian context based on the international policy and regulatory enablers, which a lot of other countries have been giving over the past 5 to 10 years. And I would like to request my colleague Akshay to please present the findings on this.
Thank you, Chandan. Very good evening to all of you. So as Chandan rightly mentioned, our next topic is policy and regulatory landscape. The core objective of this study was to understand what's happening around the globe across the battery value chain and what can be inferred from them, and what can be recommended to India, let's say, to because we are in a path of developing our own ecosystem. Adarsh, if you can move ahead, please. We'll just take you through what all is captured in our report. If you go through it, we have captured the value chain elements where we need to see what developments have been taken up. Then we looked into those global economies which has done really well in developing their own ecosystem. The key takeaway from all the study which we have done is that we can bucket all the initiatives, all the promotional measures into four areas. The first one being a national level policy or a national level plan which has been adopted by some of these countries to promote any, let's say, given area, be it battery swapping, be it a complete supply chain. So national level policy is totally required if you want to improve or encourage the ecosystem of battery in the country. Now, second bucket is subsidy and incentives, be it fiscal incentive, be it a non-fiscal incentive, but it is required if you're going to promote any industry. In a way, India is doing it, but for all those ecosystem areas where we are right now not present, this is what we can do. Yeah, talking about batteries and R&D is one part of it, which is continuously upgrading. The technologies are continuously upgrading. So a focus on improving the technology. The country needs to promote that, and which some of these countries have really done well. And this is what we have also found out through our study. We are talking about the demand side here, but the one important aspect is promoting the demand. Supply side is there, but we need to also ensure that a proper demand is in place. So these countries have also ensured, along with promoting the supply side, they are also giving focus on improving the demand so that the industry as a whole can flourish. Now, in the next slide, we'll take you through some of the key notable policy measures or a promotional measures which some of these countries have taken up. I'll just take you through that. Next slide, others, please. The idea here is to showcase what these countries have done. So first one, in USA, there's this very interesting case. So in US, they have this consortium called Federal Consortium for Advanced Batteries. Now, it's a consortium of Ministry of Energy, Ministry of they have Defense, they have State and Commerce. So what they have done is they have prepared a blueprint for the next 10 years, focusing on what US needs to do so that it can improve its supply chain across lithium ion. So they have created goals for themselves, goals in refining, in recycling, in manufacturing. And what they have said is we will take actions based on this action plan so that in the next 10 years, US has a place in the global lithium ion value chain. So it's a very impressive step which US has taken. Similarly, China has come up with a national standard for battery swapping where they are testing batteries like for 5,000 swaps, can a battery run for 15,000 kilometers? So this kind of test they have brought up. South Korea, similar to India, South Korea was facing fire issues with lithium-ion batteries. So what they have done is they have reached out to the industry, asked which technology is best for us. Based on that, lithium sulfur solid state and the lithium metal batteries were identified. Now what South Korea is doing, they are requesting or they are giving funding to the OEMs to set up either an R&D facility or a manufacturing facility in these technologies, and the country will give funds for that. Australia was facing issues with recycling because of the low volume. The business of recycling was just not feasible. So what Australia has done is they have started giving rebate on either collection, sorting, and processing of lithium end-of-life batteries. So what all these initiatives have done is it has improved the ecosystem as a whole to some extent in all these countries. So these are some of the key takeaways which we have found out. More takeaways you will find in our report, but yeah, these were some special mentions. Yeah, next slide, please. Others? Yeah, the next area was battery manufacturing. The core objective of this chapter was to understand what's happening around the globe, where India is right now, and how we see India, in the next medium to short, long term, and also to identify if you want to set up any facility, what will be the capex and the opex requirement. So that we have captured. Next slide, please. Yeah. Just a global overview. Currently, it's a state of oversupply against 530 gigawatt of demand. The world has supply of 706 gigawatt, which is 180 as an overcapacity. We looked into from where this demand, where this supply is coming. It's 80% from China. Why China is so aggressive in terms of cell manufacturing? We have identified three reasons. First of all, they have proactively strengthened their upstream, be it mining, your refining and active materials. China has all of it. So when a country is when a country is having every processing input within itself, so the domestic units can do procure all of these at lower cost. So this is the one reason. They also do have cheap labor, cheap skilled labor. I'll say cheap area rental and electricity. Different provinces have provided different subsidy, and yeah, of course, China has a high demand from EVs also. After this study, what we have identified, Chinese players do enjoy around $7 per kilowatt hour of competitive cost advantage over any other facility around the globe. We looked into the picture of the supply, the value chain picture of India. Except for the downstream side, we really don't have any presence, very minimal presence. You can see on the bottom left, our current localization level is very minuscule if we compare it with China. Only in pack manufacturing we are there. But in March 2022, when government announced the names of those players who will set up 50 gigawatt hour facility, it is not just only focusing on cell manufacturing aspect of the value chain. It is also focusing on the upstream and the midstream area because of the value addition requirement which the scheme has come up with. So the key takeaways from this study was currently India is importing all of cell requirement, but with the subsidy given, with the cost competitiveness that the Indian players will have after the ACC program, India can very well become an exporter in the medium term. We can also see not just cell manufacturing, but investments coming up in upstream and midstream expansion. We can see that. So that's another pointer. And business model shift is currently happening because Indian players right now, they don't have any technology. What they are doing is they are tying up with external partners which are giving them the raw material, the refined material, and the technology. But with R&D happening, with the technology absorption happening, this dependency on the global player will gradually come down. So this is what we have understood from our study. Next slide, please. Now, when we are talking about setting up the facility, we did speak with players who are intending to set up their facility in India. So these are the high-level numbers which we have captured. So to set up a 1 gigawatt hour facility, you will require around 5 to 8 acres of land. Whereas when we talk about the plant and equipment costing, it is somewhere 900 to 1400 rupees crore per gigawatt hour. From the OPEX side, it will cost you around 500 to 800 crore on annual basis. Power requirement usually for 1 gigawatt hour facility is around 50 MUs. Water requirement is around 8,000 per liter per gigawatt hour, and the manpower is around 750. Some of the clearances required we have very exhaustively captured in our report. You will find that reference in our battery manufacturing chapter of the report. So this is what we have captured from manufacturing. For the next, if you can go to the next slide, next topic being battery swapping. I request Chandan to take it up.
Yeah, thank you, Akshay. So battery swapping, as we all know, is slowly and steadily will be an alternative for a long time of EV charging. Adarsh, if we can move on to the next slide. So we have analyzed an overall feasibility as well as what are the various business models which can be adopted or which are currently adopted. So with respect to different segments of vehicles, two-wheelers, three-wheelers, four-wheelers or buses, what we understand is the commercial segment in the two-wheeler as well as the three-wheeler segment are more attractive towards battery swapping and represent the larger market share when it comes to battery swapping as a whole, because that's the segment where consumers have where the EV drivers in two-wheeler, three-wheeler tend to drive for longer time. EVs, three-wheelers are the last mile resort or the last mile connectivity. There is a large proportion of the entire vehicle market which is catered to by two-wheelers and three-wheelers. And hence, those are the segments, those are the consumers in the two-wheeler, three-wheelers would not like to wait for longer period of time. And hence, we understand that two-wheeler commercial as well as three-wheelers present the highest feasibility for battery swapping, in addition to the bus segment, which is anyways also touted as one of the possible segments for battery swapping business. However, as we all know that in the private segment, the private two-wheelers or the private four-wheelers might not be very attractive for battery swapping at present, because those are the areas where the consumers can have an access for private charging and may not necessarily go for swapping as a whole. With respect to business models, there are two models which are coming out. One is the fleet operator driven, in which the fleet operator who owns the two-wheelers or three-wheelers can set up a battery swapping, or it's a battery swapping services provider in which a third party or independent entity can set up the network and give the battery services to a fleet operator. There is a OEM driven model also, in which the OEM concerned can set up its own battery swapping model. There could be an integrated play also which comes in the future, which could be a combination of two models. Choosing an appropriate model is actually left to the decision of the concerned player. In case what we understand is, since it's most feasible, the battery swapping is most feasible for commercial segments of two-wheelers, three-wheelers. Initially, fleet operators can choose to set up and operate the stations themselves. However, if they want to focus on their core competence, they could use the services of a battery swapping service provider. And on the payment models, the two models which are basically emerging is the pay-per-use model, in which the user pays for the energy charges corresponding to how much the battery capacity is used. And the other model which we have gained from consultation is the battery as a service or a subscription model, in which the user signs up for a rental plan, a subscription plan for a fortnight or a month, and then in return for a fixed number of swaps. Next slide, please. Yeah, Akshay, if you can go through this.
Yeah. Thank you. So we did a financials analysis on to understand whether the business is even possible, feasible in India itself. So what we have done, we have reached out to battery swapping players, got out some details around, prepared a thorough financial model. The inputs we have showcased on the left hand side. We have prepared a model for a 20 swapping facility having 15 batteries each. Some of the input values on the left you can refer to. The key model output which our model gave was the total capex for a 20 swapping facility having 15 batteries each swapping station. The capex would cost around 5.7 crore to 6 crore. 6 crore. The NPV for the overall life of the project turned out to be around 5 crore with a very healthy IRR of 32%, with an operating margin based on the revenue figures based on the per charge rates what we have received turned out to be 27%. We have also analyzed what will be the NOx saving from this battery swapping. So for each EV which this battery swapping will cater to, for the complete life of the swapping station, it is expected that it will capture the saving of around 48 tons of NOx throughout the life of the project. So it was this is the basic model output. We also did some sensitivity around what all are the critical parameters which actually influence your business. So we have done bring up the sensitivity for many parameters. At the end, we find out that there are 3 key parameters. If you can go to the next slide, please. So these are the 3 key parameters which actually influence your business if you are a swapping player. One is your fixed swapping rate. The second one is being your usage-based swapping rate. So based on the rate you are charging to the customer, your profitability or the project feasibility varies. And the third critical aspect is your monthly lease rental. So it's one of the core operating cost which is there for the battery swapping player. And these are the 3 critical sensitive parameters which influence your profitability. And this is what we have identified from our study. Next will be battery recycling study, which my colleague Purab will take you through. Thank you.
So going through the key findings of battery recycling. So Adarsh, if you could go to the next slide. Yeah. So as Chandan and Akshay have highlighted that lithium ion is going to be the mainstay of electric vehicle industry. So there are 3 technologies which are prominent for recycling these batteries. That is pyrometallurgy, hydrometallurgy, and direct recycling. So if you could see the graph, not the graph, I would say the illustration that has been shown, you can see that pyrometallurgy is the most mature technology amongst these 3, because it caters to lithium ion, nickel metal hydride, and lead acid as well. Followed by hydrometallurgy, which looks into lithium ion and nickel metal hydride, and direct recycling, which looks into only lithium ion battery recycling. So if you go as per our analysis based on the technology readiness, process complexity, capital cost, and multiple other factors, we found out that hydrometallurgy is the best fit for recycling lithium-ion batteries as of now, and it is reflected in the choice of recycling players in India as well. They are choosing hydrometallurgy over pyrometallurgy, which is a good sign for the industry. Adarsh, if you could go to the next slide. So based on our analysis of the technologies, we found out and technologies, and also we conducted multiple primary interactions to develop a financial model around hydrometallurgy and pyrometallurgy. So our model was developed so that it takes into consideration either of the technologies, and based on that, the outputs have been showcased here. So before I tell about the outputs, I would just say that the capex for considered for a 10,000 MTPA, that is metric ton per annum plant, we have considered for hydrometallurgy. You could see on the left it's written that around 163 crores of rupees is required. It is excluding land, and similarly for a similar capacity plant of pyrometallurgy construct, it takes around 285 crores. Some major cost elements of a battery recycling plant are electricity, transportation, and battery purchase cost. I would highlight two of the major costs, that is transportation and battery purchase, and they have been assumed based on our interactions with the primary interactions with the industry players. Now coming on to the key model outputs, you could see that the NPV of hydrometallurgy plant is quite is better compared to a pyrometallurgy plant. This is mostly due to the quality and quantity of material recovered and the low capital cost incurred while setting up these plants. And at the same time, if you would see the emission savings that are coming out of these plants over its entire life cycle, you can see that hydrometallurgy plant saves around 260.8 thousand tons of green GHG CO2 equivalent, whereas for the similar capacity, a pyro plant does around 124.8. So going forward, hydrometallurgy, as per our understanding, will be the mainstay for recycling of lithium-ion batteries. Going to the next slide. So as we did a sensitivity analysis on the three major parameters that we could consider. We have taken battery purchase cost, transportation cost, and grant. So if you could see in the graphs, what I would like to highlight is that the operating window for a hydrometallurgy plant is higher. Means it's wider compared to a pyrometallurgy plant. If you see I'll just explain the graph on the left. So for battery purchase cost up to around 215 rupees per kg, the model provides that it provides that hydrometallurgy plant is feasible, whereas a pyrometallurgy plant of similar capacity is feasible only up to around 155 rupees per kg of battery purchase cost. So that shows what kind of advantage hydrometallurgy provides you when you consider this, when you have it as a choice of technology. And similarly, for getting a perspective on the subsidies or some financial incentive, we have considered a grant in our model. So because of the economies of scale in this 10,000 MTPA plants for which the sensitivity was run, these plants don't require grant as of now. But if we consider lower capacities like 1,000 MTPA, yes, pyrometallurgy plants require grant. So going to the next slide. So we have some key recommendations for developing a recycling ecosystem. So battery OEM should be encouraged to design for recycling. So they need to take into consideration whether the batteries are recyclable. Is it easy to recycle them? And they should take into consideration the the opinion of recycling players before designing their batteries. Now coming on to the next point, that is institutionalization of recovery rates, as it has been done in multiple economies around the world. So it's a must, and it is expected that the battery waste management rules, which are still in the draft stages, they should address this concern. There needs to be a development of battery reuse register, because lithium-ion batteries compared to lead acid, they have a second life usage as well, which is not there in lead acid. So these batteries there needs to be a system which captures that where all these batteries are being in their second use, and later they should end up with recycling players so that they have a higher feedstock for their business. And then another opportunity that comes with lithium ion is that the disposal. So because the black mass, that is the cathode of these batteries, is the valuable content, so we have to consider a unique disposal model where the logistics is such that there are spokes and hubs. The hub is the recycling unit and the spokes are the units which take out the black mass from the batteries. And this reduces transportation cost to a great extent. So this kind of models need to be adopted faster, and a national level not-for-profit battery collection scheme could be started, as it has been done in some European countries, to channelize these batteries to required recyclers. And EV OEMs can be brought into the battery collection cycle so that they can use their extensive service networks to channelize these batteries to the appropriate players. Going to the next part of battery reuse. Yeah, so in battery reuse, I'll just highlight others, the next slide. So I just give a brief overview that this is the flowchart that is generally used by this industry to determine what reuse method should be applied on the batteries. So you can see there are 4 reuse methods: reconditioning, refurbishing, repurposing, and reusing. So these are done on multiple levels. So some of them are done on the pack level, some are done on the module level, and some of them are done on the cell level. And the major applications of second life batteries is in EVs, which are generally brought down in their power requirement. Maybe a bus battery is used in 2-wheelers or 3-wheelers. Similarly, they can be used in grid scale energy storage. They can be used in RE projects. They can be used for backup power or EV charging. Going to the next slide. So what challenges we identified after an interaction with some players is that there are 2 kinds of challenges. One of them is the market side challenge, and the other one being the policy. So from the market side, if you see, the issue lies with reused batteries not being proven for performance, reliability, and safety. So pilot projects would be a great help in such a scenario. Now, the complexity of repurposing non-standardized battery packs. So similar to the issue with battery recycling, reuse also faces problem because of non-standardized battery packs. Since the industry is growing at a fast rate, innovation should not be coupled with standardization, but certain aspects have to be considered in order to bring in so to standardize these batteries in a form so that they can be reused or recycled later. And declining prices of new battery packs, so that because as we have seen, lithium ion battery prices have gone drastically down in the last decade or so. So these batteries have to compete with up and coming new batteries, which will be lower in cost in the future. So that is one challenge. And from the policy side, the draft battery waste management rules as were published in 2020. They were quite recycling centric. They can provide some inputs on refurbishing and repurposing, which is expected out of the waste management rules. And also there is a presence of unorganized players in the ecosystem, which drives these batteries away from consumers, from the users to collection, rather than going through the collection center, mostly sometimes to either landfills or sometimes to unorganized players. So there needs to be a system in place that these batteries go to collection centers who assess these batteries and later can provide these batteries to reuse players or recyclers. So we analyzed policies or incentives given in three major regions: European Union, the South Korea, and the USA. And we have some recommendations for reuse, which is in the next slide. So there needs to be, as I have stated, that the battery waste management rules need to consider repurposing and refurbishing of batteries, and there should be standards for reused batteries. Now also the growth of infrastructure would come out by rolling out some appropriate subsidies for projects which are using reused batteries. OEMs must include onboard diagnostics, because diagnosing these batteries after their first life usage is very important so that they can be used in second life usage, appropriate second life usage, and to ensure their safety. So onboard diagnostics from OEMs will help these reuse players to place these batteries better, and R&D should be directed towards examining battery degradation, newer technologies of battery reuse in different processes for all the 4 processes that we stated earlier for improved battery management. So these are our recommendations from reuse. So
So that is in short the key findings of the report on the battery ecosystem overview. We would like to request all of you, all the audience, to please go through the detailed report which is available in public domain for more detailed insights on that. Back over to you, Sushovan.
Thank you. Thank you so much, team. Thank you so much, Deloitte team, for the wonderful presentation of the entire battery report that has been developed by the Deloitte team and based on various stakeholder consultations. We would also like to thank the stakeholders who have supported the team in designing this entire workshop. Another work package that is currently being worked upon in continuation to the findings that Deloitte has presented is our model documents that are being prepared for designing battery swapping, battery reuse, and battery recycling guidelines for a country like India. We would be having another workshop so as to take forward our findings on designing those guidelines or model documents in the next workshop. So before this ends our session 1 on battery ecosystem report with the launch of the battery ecosystem report. And the link to the report has already been provided in the chats of the comment section. as well as our DLGM portal. We would be happy to hear your views on our report. And before we start the session 2 on battery recycling, we would like to take a 5 minutes break before we start our session 2. So stay tuned. We will join the event within 5 minutes, and looking forward to seeing you all again on in our session 2. The link remains the same, so you may wish to stay on this link as well. So stay tuned. See you all in 5 minutes. Thank you. We will start in 2 more minutes. We are waiting for few of our speakers to join. Once everyone joins, we will start within 2 more minutes. Thank you, everyone. Thank you, everyone. So with now we will start the session 2 on battery recycling. Uh, the report 2 that we plan to launch is on international review on the recycling ecosystem of electric vehicle batteries. With the aim to attain energy security, reduce dependency on international market for oil, and the need to prohibit carbon emissions from transport sector, this has led to a rapid shift towards electric mobility. But this also mandates the need for efficient battery technologies, given that the minerals required for battery manufacturing are scarce in terms of running the sector for many more years to come. Hence, recycling of batteries and reuse of batteries becomes imminent. Currently, in the first session that has been presented by the Deloitte team, as we said, India-specific guidelines for developing mm, India-specific guidelines for developing battery recycling, battery reuse, and battery swapping are being worked upon by the team. Though these are reference or model documents we are planning to create for the country or the states to refer to. But then battery recycling definitely becomes one of the most eminent requirements to sustain the electric mobility sector for long. The current study that we are planning to present under our session 2 includes a holistic overview of the various international regulations on EV battery recycling in 5 major countries. First is Germany, including rest of EU. Second is California in the US. Third, China. Fourth, Japan. And lastly, South Africa. The report has been launched in collaboration with Agora, Verkehrswende, and IIT Bombay. So without further ado, I would like to invite Mr. Christian Hochfeld, who is an executive director at Agora Verkehrswende in Germany, to provide the special address and launch the report. Over to you, Christian.
Thank you very much, Sushovan, and I hope that you can understand me. Maybe you can give me a sign. Wonderful. Then it's my great pleasure and honor, ladies and gentlemen, to also welcome you in the name of Agora Verkehrswende. Verkehrswende is a German word, different and difficult to pronounce, but it stands for transformation of the transport sector, decarbonization of the transport sector. This is our aim, and therefore, in the name of Agora, I'm very happy to welcome you to the launch and presentation of the report on battery recycling, which Sushovan mentioned already. Just a short remark also from my side. Last year was a very special year because the Olympics were delayed by 1 year due to the COVID crisis. But what we also saw is that climate action and climate protection also got somehow Olympic. And you might know this Olympic theme, which is higher, faster, and stronger. What we saw all around the world that, we set higher goals in decarbonizing the economies. Countries all over the world, pledged to net zero. Currently, 90% of the emissions worldwide are under pledges that decarbonization takes place either at mid-century or shortly after it. Secondly, everything is not only higher but faster. So the implementation of climate action needs to be earlier than expected. And I would like to give the German example, which I think is also very prominent, because our government was overruled by our constitutional court only last year, that they saw that the German government did not enough on climate change, although we had already targets of reducing the emissions compared to 1990 by 55% in 2030 and being carbon neutral by 2050. They said it's not enough to keep the freedom of the young and coming generations, that they also can have a prosperous life and with a lot of welfare. So Germany had to also have earlier and higher targets. So we're currently driving for a 65% emission reduction in transport and climate neutrality by 2045. And we all know that not only for countries like Germany or others, that this is absolutely, Hercules work and Hercules task to overcome. And therefore, I think it's even more admirable and applaudable that India also last year mentioned to be climate neutral by 2070 and also thought on the question and put some thought on the question, what does it mean for the transport sector? Signing the Glasgow Declaration of acceleration of the transition to electric vehicles with a target to be to have every new sales, zero emission by 2040 only. That means, as we have very comparable targets in Europe now, we are talking about the phase out of the combustion engine in 2035 and 15 million electric vehicles on the road, every third vehicle on the road electric by 2030 in Germany. That means that there will be a high reliance of climate action in the transport sector on electric mobility. So, and we learned also from the report of the ecosystem for batteries that therefore we must make sure that we really assure that we have enough resources ready and that we really are able to deliver electric vehicles to the markets. And we do this in a climate sound way. Not only the use of the vehicles, using renewable electricity in ideal case, but also greening the supply chains, especially the energy intensive supply chain of the battery, which means at the end, we have a trifold benefit if we really focus on battery recycling. First of all, we make sure that we get the resources, the very valuable and scarce resources out of the batteries again to reuse them, and therefore making the market a little bit more independent from the turbulence of an uptaking market where we have to open mines and have to secure and build up new value chains and value nets which have not been before. Secondly, we make sure that we produce batteries as green as possible, as environmental sound as possible by recycling, because the recycling often uses less energy and causes less environmental issues. And thirdly, it's all about the acceptance of the consumer for the cars and the vehicles, because we know that there is a lot of, let's say, reluctance and also some uncertainty at the consumer side, that they say, well, we heard about electric mobility, but even if the electricity we use is green, we see that there are problems, environmental problems in the batteries. And this is very much because we had so much problems and environmental issues with batteries, with lead acid batteries and nickel cobalt batteries in the past, that we have to make sure that everyone, even the consumer, can be aware that these batteries are recycled in an environmental and social sound way, and that we do this economically efficiently. This is also important to drive down the costs of the electric vehicles, which is also a burden for a huge and fast deployment of electric vehicles. So in this sense, I think it's very wise what the Indian government did to overlook the huge global market on battery recycling technologies, battery recycling approaches, to see what would be fit best for the Indian situation, and maybe where it's possible to align strategies and approaches to drive down the costs of battery recycling system and learn from each other how to build up very functional and a very eco-efficient battery recycling system in the future for India. And we have to be quick. We heard, or we always hear, well, it takes some time, and now the first cars are coming to the market, and when the batteries are back, it will take some time. No, we have to do this as fast as possible. First of all, because there will be also waste from the production. We know that especially building gigafactories, there's a huge, before this factory will be efficient, there's a huge amount of battery waste, which needs to be recycled soon. And secondly, we also will see a very fast uptake of the market if we would like to meet our climate goals. And therefore, battery recycling systems have to be put in place right now. And in this sense, it's my great honor and pleasure to officially declare this report as launched today. The report titled International Review on Recycling Ecosystems of Electric Vehicle Batteries. I've never seen such a nice launch of a report here in Germany. I think we can already learn a lot on this. And with having said this, again, it was my great pleasure and my honor to be here. And I'm very much looking forward to the discussions. And I hand over back to my honest colleagues and dear colleague Sushovan in Delhi. I hope you don't soar from the heat in Delhi. And well, greetings from Berlin.
Thank you so much, Christian. We are managing the heat. Yeah. Thank you so much, Christian, for your thoughtful words, and thank you for giving such a wonderful overview on what is currently happening in Germany and what all is actually required to develop such a sustainable battery recycling ecosystem. Thank you so much. Next, I would like to invite Dr. Matthias Buchert, Head of Division for Resources and Transport at Öko-Institut, Germany, who would be presenting his views on the recycling perspective around Germany and Europe. Welcome, Dr. Buchert. Over to you.
Thank you very much. Should I share my slides for myself? Yes.
Yes, that would be great.
Yeah, it's no problem. Just Just a second. So I guess you can see my slides. Yeah. Good afternoon, ladies and gentlemen. I'd like to give you a short perspective from Europe and Germany, and I will focus on Europe because Germany is part of Europe, and for the battery issue, the European Union is decisive for this issue. Okay. Just a short look into the past. Our current regulation is the EU Battery Directive in Europe, as well as in Germany, of course, and it's from 2006. And in 2018, our institute carried out a study for the European Commission with partners to evaluate the current framework, the Battery Directive. And to make a long story very short, we revealed many weaknesses, and that's not a big surprise, because you have to take into account that the 2006 directive focused mainly on to avoid negative impacts on human health caused by toxic heavy metals like lead, cadmium, mercury, and so on. So it was more to avoid negative impacts on human health and not focus mainly on resource issues. And to give you an example, lithium-ion batteries are included in this 2006 regulation among other batteries. So it's clear, very clear, that this current directive on batteries in Europe is outdated. In the next step, we carried out, again with other partners, the so-called impact assessment studies for the Commission to prepare proposals how to increase the positive impacts of a regulation for Europe. Yeah, there are two reports, and in end of 2020, the European Commission published a comprehensive proposal for a new EU battery regulation. And it's not just, in our view, a new dimension in environmental policy, this proposal, because now the EU wants to pave the way for sustainable batteries over the entire life cycle. So that's a new perspective. Core issues are ambitious environmental and social standards for primary raw materials, minimizing the carbon footprint in the manufacturing chain, of course, increasing useful life, safety, and second use, and significantly improve recycling by increasing collection rates, recycling rates, etc. Once adopted, an EU regulation, and that's also a difference, has a direct effect on all EU member states, because it's directly valid for all EU member states, and that means, of course, a couple of advantages: a better harmonization for all the involved actors within the European Union. Just at a glance, the 13 measures from the proposal of the European Commission, there are new classifications and definitions. There are still ongoing discussions on this. A new category for electric vehicle batteries, bigger than 5 kilogram industrial batteries, and a distinction from the portable batteries. Very important also, second life for industrial batteries, obligations for this. Very important again, higher collection targets for all kinds of portable batteries, 65% from 2025, 70% from 2030, based on the quantity placed on the market or put on the market. Further measures, new collection rates for starter as well as for EV and industrial batteries. new reporting systems based on the existing systems of the End-of-Life Vehicle Directive and the Waste Framework Directive. And yeah, I think number 5 is really core recycling efficiencies and specific recovery rates. For lithium-ion batteries, enhanced recycling efficiency 65% by 2025, 70% by 2030. But for all experts, much more important are the specific recovery rates, because it's not decisive to recycle oxygen or whatever, but the core elements. And for the core elements of lithium-ion batteries, there are ambitious targets for nickel, cobalt, and copper. 90% in 2026 and even 95% recovery rates in 2013, and for lithium 35% in 2026 and 70% in 2030. The proposed recovery rates for lithium are still lower compared to the other key elements because of the chemical performance of lithium. It's more tricky than, for instance, copper or cobalt to recycle lithium, but there are ongoing research and development projects. I will come back to this issue later. Number 6, this is completely new, CO2 footprint obligations for industrial and EV batteries, performance classes and maximum limits in the future for batteries as a conditions for placing on the market. Number 7, performance and lifetime of rechargeable industrial and EV batteries. There are information requirements on performance, durability, etc., etc. As well, number 8, non-rechargeable batteries, minimum requirements again for performance and service life and minimum threshold values. And number 9 is also new, very new. It's the secondary metal content obligations in industrial EV and starter batteries. For the lithium-ion batteries, there are obligations for new lithium-ion batteries. For 2030, 4% for lithium, 12% for cobalt, 4% again for nickel, as secondary metal content in new batteries. And these values will increase to 2035 to 10% for lithium, 12% nickel, and 20% cobalt. That seems to be quite low, but you have to take into account that we recycle into a rapidly increasing e-mobility market. So a few years later, of course, there are much higher recycled content figures possible. The last 4 measures, the extended producer responsibility, it's very important to create a level playing field and to buy better and more specific requirements for the stakeholders. Furthermore, design requirements for portable batteries, better removability and interchangeability from devices. And number 12, also very important, provision of information, and the keyword is here the battery passport. Yeah, there are huge projects currently ongoing to work out the details for such a digital battery passport, which will include important information on battery materials, the chemistry, state of health, whatever, and so on. And last but not least, there are also number 13, supply chain due diligence obligations for raw materials for batteries, mandatory due diligence for the industrial and the EV batteries. But this is just the comprehensive proposal of the European Commission. There are, of course, ongoing discussions. And there now we have statements from the European Parliament and the EU Council. And of course, there is a demand of some changes in detail. I've listed here the main changes from our point of view demanded by the EU Parliament, and very important, the EU Parliament asked for higher recovery rates for lithium, namely 70% by 2027 and 90% by 2031. So there is a difference compared to the proposal of the European Commission, and there's an ongoing assessment what will be the best targets for the lithium from the lithium-ion batteries. And a further important proposal by the EU Parliament is a definition of a new battery, an additional battery category called the battery used for traction in light means of transport. That's e-bikes and e-scooters, small vehicles, two-wheelers, etc., with a couple of obligations like also carbon footprint declaration and specific collection rates. 75% by 2031, 2035, and 85% by 2030. And a third discussion currently is the EU-wide deposit return system for batteries. This was not especially foreseen by the EU Commission, but the EU Parliament asked for again an assessment, maybe whether it's possible for portable batteries of general use that should be assessed. Maybe there are a possibility to create a deposit return system, but it's in the details. It is a really complex issue. In one of my last slides, I'd like to show you 2 points from our current work for the European Commission. Again, we are. It's our job to check the current status and the foreseeable developments regarding the recovery rates of lithium from waste batteries from a technical and, of course, economic perspectives. This is current work for our institute, and we have to deliver a report to the Commission in 2 weeks. And again, also ongoing is an evaluation of the feasibility of introducing, I mentioned it before, deposit and refund schemes for portable and light means of transport, LMT batteries for pedelecs and e-scooters, etc. A short outlook. The proposal on the EU batteries regulation will be a milestone, if implemented, of course, in the EU environmental policy and an important building block of the European Green Deal, the blueprint for other regulations, of course. And the market ramp-up of electromobility and the related industrial policy of the EU, especially this gigafactory activities for battery cells in Europe, provides a new strategic perspective. It's not just about waste, but about optimizing the entire life cycle of batteries, a safe and ethically justifiable supply of raw materials, as well as supporting the EU's climate goals. So it's a bigger picture compared to the directive from 2006. I'd like to thank you for your attention. Thank you very much.
Thank you so much, Buchert. Thank you, Dr. Buchert, for presenting your views on entire Europe and Germany. The views were really thoughtful, and I am sure these will give few reference points for India, how to design the entire ecosystem. Thank you so much, Dr. Buchert. Next, I would like to invite Ms. Yidan, who is an associate researcher at International Council for Clean Transportation, ICCT, in Beijing, China, to present her views on recycling in China. You are on mute, I believe.
Thank you. Could you see my screen now?
We are unable to see your screen right now.
Okay. Okay. Good afternoon, ladies and gentlemen. I'm Yidan from the ICCT Beijing office. First of all, congratulations on the accomplishment of the two great reports. They are the most comprehensive global review on electric vehicle battery recycling that I've read so far. In fact, ICCT is conducting some EV battery recycling policies and other research recently, but we would like to share our insights when we have more concrete findings. So for today's presentation, I will briefly introduce the EV battery recycling policies and regulations in China, and the major challenges that China now faces. The EV battery recycling companies in China have been in heat since last year due to the upstream raw material prices fluctuation. And the price of battery-grade lithium-ion carbonate and the electrolytic cobalt went up to nearly 6 and 2 times, respectively, by the end of 2021, compared with the price earlier that year.
Miss Yidan, sorry for breaking you in between. If you are presenting any presentation, we are unable to see the presentation.
Please allow me to reshare my screen.
Sure.
Okay. Can you see my screen now?
Now we can see your screen. Thank you.
Okay. Okay. So I need to restart over, right?
I believe so. Sorry for that.
Okay. So please allow me to skip the beginning of this presentation and go ahead to the main contents of it. Okay.
Sure.
The EV battery recycling companies in China have been in heat since last year due to the upstream raw materials, the price fluctuation, and the price of battery-grade lithium carbonate and the electrolytic cobalt went up to nearly 6 and 2 times, respectively, by the end of 2021, compared with the price earlier that year. And as a result, the price of recycled lithium iron phosphate materials jumped from 4,000 yuan per ton in the early 2021 to 80,000 this February. But China's EV battery decommission heat has not yet come. In China, new energy vehicle refers to battery electric vehicles, plugged-in hybrid electric vehicles, as well as fuel cell vehicles. And by the end of 2021, there were already nearly 8 million new energy vehicles on the road, and over 80% of them were battery electric vehicles. If we assume the lifespan of batteries on a passenger car in China is 6 years, a more enormous wave of battery decommission will start in next year. According to the estimation of the National Big Data Alliance of New Energy Vehicles, the potential size of EV battery recycling market in China in less than 5 years will be huge, almost 4 times than that in 2021. Now I'm going to introduce some significant EV battery recycling policies and regulations and their timelines. The first dedicated EV battery cascade utilization and recycling policies was issued in early 2016. Except for the technical requirements on battery dismantling, storage, and transportation. The policy also clarified that both EV producers and importers, as well as battery producers and importers, are the primary responsibility subjects for the reuse and recycling of decommissioned EV batteries. This policy also formally announced the national decision to establish this battery recycling and traceability system. At the end of 2016, China enlisted EV as one of the major products to adopt this extended producer responsibility system and planned to establish a sound system for the relevant policies. The new energy vehicle production approval regulation issued in early 2017 required new energy vehicle manufacturers to report the reuse and recycling status of their EV batteries annually. And in the middle of the year, China's national coding regulation for EV batteries came out. The interim measures for the administration of EV batteries have provided more details on the responsibilities of both EV manufacturers and producers. Particularly, battery producers are required to code their batteries with cooperations from OEMs. In August 2018, China started implementing this traceability management of EV batteries. And this policy have the relevant policies had clear requirements on what kind of traceability information to report and who should report the information, and also what is the report frequency. In late 2019, China's first dedicated regulation on EV battery cascade utilization and recycling industry was issued. The regulation had requirements on the relevant plant construction, technology adopted, equipment used, and also the recovery rate of nickel, cobalt, and lithium. Then China initiated pilot programs on battery cascade utilization and recycling in selected areas, such as Beijing. And the most recent relevant policies have provided more detailed requirements on battery traceability information reports and the battery cascade utilization methods. China has built a national digital platform for EV battery recycling and traceability. And this platform was started operation in 2018. And so far, 87 items of traceability information have been collected. And over 400 EV and battery enterprises, as well as over 5 million new energy vehicles, have been registered on this platform, involving over 200 gigawatt-hour cumulative battery capacity. So ideally, this platform could allow the information of EV battery products to be traceable along the production, sale, repair, reuse, and recycling processes. And along the way of building this platform, the relevant policy system, China encountered 3 major challenges. First, the current battery recycling and traceability platform relies heavily on self-reported information from EV manufacturers and battery producers. So the accuracy and the quality of the information on the platform are very low. Second, most of the decommissioned batteries are not treated in the proper ways as we expected, because so far only 56 companies in the nation are regarded as certified. A certified company here means that the one that meets safety, environmental, and technological requirements. However, currently over 40,000 battery recycling relevant companies have got their business registration, and nearly half of them was just registered last year. So those uncertified companies can pay at a lower price to buy the decommissioned batteries than the commissioned ones. So because they have lower cost. And finally, most of the EVs recycled at current stage in China are lithium iron phosphate batteries. And the price of the recycled chemicals is much lower than the chemicals such as cobalt and nickel. So those certified companies have found it is difficult for them to sustain themselves currently. And that is all for my presentation today. I would like to take some questions and other comments. Thank you.
Thank you so much, Ms. Yidan. It was a wonderful presentation and overview on the entire battery recycling ecosystem in China. We'll look forward for the questions in the chat, and we'll let you know when some questions come up. Till then, thank you so much for your presentation.
Thank you.
And thank you so much. Next, I would like to invite Professor Zakir Hussain Rather from Department of Energy Science and Engineering in Indian Institute of Technology, Bombay, to present his views on the entire recycling ecosystem in 3 major countries, that is Japan, California, and South Africa. Off to you, Professor Zakir.
Thank you very much, Sushovan. Let me share my slides and please help me if you can see the slides in presentation mode.
Yes.
Okay, so good evening, good afternoon to all the participants. So given that the earlier presenters have already discussed the broader spectrum of the battery recycling, this presentation is focusing on the analysis of this battery recycling schemes and the experience from these countries, that is Japan, California, and South Africa. So this is the outline of this presentation. Little bit introduction about the battery recycling. Then we'll move to the Japan, the battery recycling in Japan, California, South Africa, and finally conclude this presentation. So if you look at this slide, predominantly our batteries that we are talking about here is lead acid and lithium ion batteries. So lead acid batteries, given that their their technology is quite mature, there is an established recycling process that lead acid batteries have. If you see here on the left top of this slide, you can see that the battery has 3 components that go into this recycling process. One is the grid, the electrodes of the battery that are being used for this recycling. The lead grids are used for making new batteries. The second component of the battery, used battery, is the acid, the chemical of the battery that comes out, which are actually being used for other applications, for example, as cleaners or some other similar applications, not actually again as an acid for new battery. And the third component is the casing of the battery, that is plastic primarily, which is actually recycled into new plastic and then use it in this making new batteries. When you come to the lithium ion batteries, the recycling is actually a bit different, and relatively it's not a mature this established recycling framework that is there for lithium ion when you compare it with the lead acid batteries. You can see here there are various methods of this recycling. One is pyro, that is heat-based, thermal-based processing of this recycling of lithium-ion batteries, which is an energy-intensive process that you crush and smelt the the lithium-ion battery material, and then you take the components relevant elements from that, process it, these second life batteries, used batteries. The other is hydro, which is actually the aqueous solution based process, where you actually follow these chemical based approaches to recycle this lithium-ion battery. And third is the direct recycling, where you take the components of the lithium-ion battery and then you recycle them. So these are the general approaches of this recycling of these lead acid and the lithium-ion batteries. So moving to Japan, Japan has been one of the pioneering countries in the recycling of these batteries. They have relatively an established structure even for the lithium-ion battery recycling. As you can see here, there has been this law for the promotion of efficient utilization of resources in 2001, which is relevant to this battery recycling. Then promotion of reuse and recycling used small electronic equipment 2013. Then this JBRC is this organization in Japan, which is actually responsible for collection of these non-industrial battery technologies, including lithium-ion batteries, not the vehicle lithium-ion batteries that we are talking about. And then lead acid battery recycling association is there since 2014. So you can see here obligations of these different stakeholders that are there in the structure currently in place in Japan. So this JBRC is actually, as you can see, this for this rechargeable battery recycling. How it works is consumer actually has this used battery that is given to the collection boxes set up by JBRC, associated with the JBRC, and then once these collection boxes are filled in, and then there is a collection request sent to JBRC. JBRC engages the third party transportation companies, which actually transport these batteries, and then these used batteries go to the recyclers, and then it's being used for some part of it is used for as a resource for battery manufacturing and other users, and some disposable materials also there in this business. You can see here there are annual membership fee that these manufacturers of the batteries are providing to this JBRC to maintain this recycling process. This is this lead acid battery ecosystem that is in place in Japan, which is in line with the introductory slide where I talked about the lead acid battery recycling process. Lithium-ion in Japan is actually being responsibility of recycling. The responsibility is kind of given to the manufacturers. OEMs are responsible to collect their own batteries that they actually produce. So therefore, it is being regulated through these OEMs themselves, that they actually collect their batteries in this overall recycling process. So these are some of the players that you can see that these recycling of these batteries is actually done in Japan, primarily driven by these OEMs for lithium-ion batteries. So coming to California, California also has been historically quite progressive in terms of the battery recycling. You can see that there was a policy published in recent one in 2022, and there has been this Lead Acid Battery Act that is actually focusing on the lead acid batteries. There is this Common Battery Recycling Law for Rechargeable Batteries Act that is again in place for this recycling of the batteries. There is no cost actually borne by the user, the customer, which is actually providing the battery back at the time of the return of these batteries in this recycling framework. But there is a battery cleanup fund that is actually to be given and is taken from both the customers and manufacturers. Is relatively low, but it is there in place in maintaining this battery recycling process. Then there is this EPR guidelines are in place, and this is lithium-ion battery ecosystem, recycling ecosystem that you can see. User actually can give this third-party the user battery and can actually swap with the new battery with the third party, or it can actually give to the dedicated battery outlets there that are established by the manufacturers or through the with the help from the manufacturers OEMs of the batteries, and then they are actually transported and used by the manufacturers. If it goes to this third party, again there are third party transport agencies that are involved, and that they which take these used batteries to the recycling facilities, and then recycling facilities go into the whether it's second life battery or it can be the manufacturer. It is given to the manufacturers themselves for further recycling of these lithium-ion batteries. This is the lead-acid battery recycling structure. Again, it is in line with the recycling process that I mentioned in the beginning in the introductory slides for the lead-acid batteries. So here you can see the customers are giving $1 this clean fund to the government for maintaining this recycling structure for these batteries. So coming to South Africa, there have been also some of the policy initiatives in place in South Africa which pertain to these handling the used batteries. ERP guidelines are in place. Lithium and batteries lithium batteries are not much in the market at the moment, but still there are these, you can see that battery levy charges are actually being levied on the petrol and diesel to promote EVs in South Africa. And there are several standards that are being used for scrapping and recovering of the motor vehicles that are actually applicable to this battery recycling in South Africa. This is the lead-acid battery recycling schemes that are in place, where consumer can actually give the battery to the collection centers, and then battery recycler actually takes, and then there is scrap of the plastic secondary electrodes that can be used for the building new batteries. And then, of course, as I mentioned, the acid is also being used for different purposes in this whole recycling structure. This some of the examples of this lead-acid battery recycling schemes in South Africa, as you can see. This first national battery recycling and this BHG battery recycling schemes that are there, in place in South Africa. So that is that was summary of the battery recycling processes in these different countries. So to conclude, that we can see in Japan has this act of promotion and effective utilization of resources which have been motivating these various stakeholders involved in the battery business for their voluntary collection and recycling schemes in the country. So to handle these small portable batteries, not the vehicle batteries primarily, let's say for four-wheelers, this JBRC has set a mechanism that I talked about earlier for this supply chain mechanism for the recycling of these batteries. And coming to California, as we observed that California has the latest policy in 2022 for recycling of the lithium-ion batteries that is in place. And they have earlier, related regulations already in place related to this battery recycling. South Africa, as I mentioned, growth of this EV market is being forced in there, and therefore there has been initiatives in developing these policy for handling these lithium-ion batteries as well, in addition to the lead-acid batteries that were there in place. With this, I would like to conclude this presentation on this analysis of battery recycling schemes and structures, frameworks, and the supply chain in these different countries that I spoke about. With this, I would like to hand over back to Sushovan. Thanks.
Thank you, Professor Zakir. Thank you for wonderfully presenting the recycling ecosystems for Japan, California, and South Africa. It was really great to see the entire ecosystem, how it pans out across various economies. With this, we end the second session on battery recycling. And lastly, on this, I would like to invite Dr. Indradip Mitra, who is the team leader for e-mobility under the Indo-German Energy Program and the country coordinator for NDCTR India component in GIZ India. On to you, sir.
Thank you, Sushovan. I hope I am audible.
Yes, sir, you are audible.
So very good evening from Delhi. And I'm a little sorry that it extended the time for 2 hours. We are slightly delayed. However, you could understand that the spectrum of the coverage of these two reports are quite complex and quite broad, and therefore I believe it's not that unjustifiable to exceed the time for a little bit, like 5 minutes more. It's customary to actually express the vote of thanks, and I would like to thank first that Mr. Sudhendhu Sinha from NITI Aayog actually kindly inaugurated our first report, and also our partner, Mr. Hochfeld from Agora, also kindly inaugurated our second report. I do believe that as the audience, if you read the two reports, you will get a lot of information and valuable information so that you get the benefit out of it. And it should be acting as a guide for policymakers and stakeholders. That's the main point of it. So our sincere thanks to our project team for the first report. It's Deloitte. And for the second report, this is a combination of our own GIZ colleagues, namely here Sushovan and Tony, but also our partners from NDCTIA project from Agora. And it is supported and reviewed by also Öko-Institut, Dr. Buchert, and others. I'm really very thankful to all of them. And I would like to also say that ICCT, being one of our partners of NDCTIA project, extended their support to speak about China in this event. So it's our sincere gratitude for them. I would like to say that all of our team members in NDCTIA project from the GIZ side, our internal team here, worked quite a lot on this for the report, for the consultation process, and also for the organization of this event. And particular thanks also goes to Mr. Chandan Dikshit and also Mr. Purab and Mr. Anish Mandal from the Deloitte team to have a lot of discussions and thought-provoking sessions with us. I would like to say that perhaps you could notice from Dr. Buchert's speech that in Europe now the focus has been shifted to the life cycle concept and not only as a micro waste management point of view. This could be a very important signal for us because in India, as part of our NDCTIA project, we started focusing on life cycle analysis angle. And also our partner, International Transport Forum, they also under the NDCTIA project India component are promoting life cycle concept. And this should be our next way to go in the future, and particularly in the context of overall decarbonization of the country, and particularly for the transport subsector. So with this, I would like to also express thankfulness to the audience that it's over 2 hours and you are all here. So thank you very much. We are progressing in NDCTIA project for India component, and we will continue to work more on recycling and reuse and life cycle analysis concept. So having said that, I would like to conclude this event. Thank you very much.
Thank you so much, Dr. Indradip. And as Sir said, thank you everyone for hearing out patiently, hearing out the speakers, and especially thanks to Mr. Sudhendhu Sinha from NITI Aayog, Dr. Damm, Dr. Indradip Mitra from GIZ, speakers from Deloitte, Agora, Professor Zakir from IIT Bombay, Dr. Buchert from Öko-Institut, Ms. Yidan from ICCT, China, for wonderfully presenting your views on all the topics. And The links for all the reports have already been posted on the chats. You can find the links to the report in the chat section of this workshop. Also, please do visit our digital library for green mobility. We are trying to make it one of the largest libraries on anything related to any paper, any report, or anything related to green mobility. Please do visit. Please do register yourselves there. Also visit our NDCTR page for various such resources on decarbonization of transport. My name is Sushovan and looking forward to seeing you all in future such events. Thank you, everyone.